All right, we just arrived at Devil's Tower.
Devil's Tower is one of the more iconic geologic sites in the world, and one of the most spectacular examples of columnar joining. Each year, about 500,000 people visit this striking national monument made up of shallow, intrusive igneous rocks. It is a steep-sided igneous body of phonolite porphyry surrounded by its own debris field, by Mesozoic sedimentary rocks, and by the Belle Fourche River.
Taking the students on our first hike this evening before we get some dinner. Going along the Spearfish Trail here. Gonna go look at the sedimentary rocks that make up the rocks that the Devil's Tower intrusion is intruded into. This is where the Mars rover conspiracy started. They just run these things around out here.
Right.
So the red soil and rock here is the Spearfish Formation. It's Triassic in age. See the same formation over in the Black Hills.
The oldest sedimentary rocks exposed here are the red to maroon siltstones and shales of the Triassic Spearfish Formation. The spearfish is primarily made of quartz, but the dark red color is due to the presence of the iron oxide mineral hematite. It also contains gypsum layers and gypsum veins. During the Mesozoic, when these sedimentary rocks were being deposited, the magma that would eventually form Devil's Tower hadn't yet melted out of the deep crust and wouldn't arrive on the scene for another 100 million years or more.
So we're in the Spearfish Formation, and right here there's a really cool gypsum vein. Beautiful little fibers indicating that the crack was pulling apart. Fibers are growing in. Here's a block of the Hulett Sandstone, which is this yellow fine sandstone that sits above Triassic. And if you run your fingers across this, you can feel that it's asymmetric. So here this evening we are basically introducing the students to the two rock units, Triassic Spearfish and the Jurassic Sundance. And those two units are basically the context, the country rock that the Devil's Tower intrusion is cutting through. So tomorrow morning we'll head up to the tower itself and take a look at the rocks that make up Devil's Tower and the intrusive material, the columnar joints, etc., etc.
The spearfish is overlain by the Sundance Formation, consisting mostly of shale and sandstone deposited in the Jurassic Sundance Sea. The Hulett Sandstone is a prominent member, a visibly striking yellow sandstone that crops out in cliffs around Devil's Tower. Ripple marks are common on its bedding planes, indicating current directions. The sedimentary rocks surrounding Devil's Tower are a big reason for why this place is so beautiful.
So this morning, going up there. Actually, we're not really going up there. I mean, we're gonna walk around it. We're not really gonna climb it or anything. That'd take a little longer than what we got here. All right, so here's our trail. I'm gonna take this route.
The phonolite that makes up the tower itself is coarsely porphyritic. Large phenocrysts of feldspar are surrounded by a fine-grained gray groundmass. Pyroxene, sphene, analcime, and nepheline are also present. The porphyritic texture suggests that the magma cooled in two stages. At first slowly to allow time for the large feldspars to grow, and then more quickly to produce the fine-grained matrix. Geochronologic data indicate that this magma crystallized to solid rock about 49 million years ago in the Eocene epoch. The top 150 feet of Devil's Tower is much more weathered than the rest, including horizontal joint fractures and the beginnings of spheroidal weathering. When the tower formed, it was likely covered by several hundred feet of sedimentary rocks that are now worn away. These Cretaceous and younger sediments are present in other areas of the Black Hills.
So a number of things that we talked about with the students. Number one, we talked about the columnar joints and how those form in response to the stress field. We talked about the texture of the rock itself, which is porphyritic phonolite, what that means in terms of the cooling history of the magma. We also talked about, way up at the top, there is a difference in the top of the tower in terms of the amount of weathering that the rock has experienced. And it looks like it's a fairly distinct divide between the top and the bottom. So that suggests that there might have been a second period of uplift to expose the lower parts of the tower, and that the upper part of the tower had been sticking up exposed for some time, being weathered, while the rest of this down here was still buried below the surface.
The level approximates the former level where the Cretaceous Fall River Formation would have been. The Fall River Formation is a resistant layer in the region. Eventually, the Fall River Formation was removed by erosion, along with other less resistant sedimentary layers, and the tower was exposed as we see it today.